Here we have f of x being this red line, and it's a linear line. Then we have g of x over here, which is a quadratic. And as we see, it is represented right here. And then we have h of x, which has been created by adding the two equations together. And we've created another looking loop. So if we change the slope of the linear line to negative, it makes the line straighter. But as we make the linear line positive, it makes the shape move. As we move the y-axis, it elongates and brings down the y-intercept of our h of x. And if we move the parabola, it changes how wide or how narrow the curve is, and also how the curve looks. And then if we move the y to negative, it moves it negative. If we move it positive, it moves it also positive. Well, what would happen if we were to subtract these two equations? It reverses how it used to look. So now instead of being on one side, it's flopped. Let's move the slope. The y-intercept, still moving it up or down. Whoop. Now we have opposite pictures of the parabolas. And we have a very funky shape, but it is never touching the y-axis at all. See? It'll go as close as it physically can, but it'll never touch. It just moves. When we change the y-intercept, it just moves the graph up or down. So right now it's up and then down, changing the pitch of all the equations. But what would happen if we multiplied them? Now we're multiplying this linear line times this quadratic to create h of x. We're getting a whoop and changes how the graph is and where it is when we change the y. But now we're getting a downward parabola, and it looks like a linear line, and our linear line hasn't moved. And they come together, and now they've crossed down, and that's by changing the y-intercept. And that's by multiplying these two. We've done this. But there's still one more question. What happens if we divide the two equations? Ooh. We've turned our h of x into two lines. And now back to one, and then there's the two right there. So kind of like the last time, just right here, meaning they'll never touch at 3.1, and we change it. What happens if we change the slope? Changes where they are. Now we have lines that are never touching the y-axis but are right here, touching at 0, 0. By dividing the two equations to create h of x, we've created a whole different mess of things.